Hello! In this video, we will explore problems with polygons and their attributes. Some key terms and properties are written on the left side of the screen. Just to state a few examples of polygons: triangles, rectangles, hexagons, octagons, and more. Now let's look at some examples. So looking at this example, we have a four-sided polygon and an angle that has a variable in it. So we want x. Then use that to find the angle. From the properties on the left, we can write down what the formula for the sum of all interior angles is. N minus 2 times 180. Again, we know we have a four-sided polygon, so n equals 4. Now let's write the sum of all the angles and plug in 4 for n. Now we have an equation with just x, so we can solve it. Now we just simplify a bit. Isolate the x term. Divide by 2 to get x by itself. And we get x is 28. So now we can plug that into the expression 2x minus 7 to find the angle. Plugging in x and evaluating, we end up with the unknown angle being 49 degrees. Let's try another example. Similar to the previous example, we want to find x and the unknown angle. So we want an equation summing all of the angles. Make note, there are 5 sides in this polygon, so n equals 5. So let's write our equation summing all of the interior angles and setting it equal to 5 minus 2 times 180. Now we just simplify and solve for x. Here's some music while I'm just simplifying. Now we have x squared on one side and 25 on the other side. So we can use the square root property to solve for x here. Using the square root property, we get x equals plus or minus 5. Now we just need to plug x equals 5 and x equals negative 5 to find the unknown angle. And we get 51 degrees when x equals 5. Plugging in x equals negative 5, we get the same result of 51 degrees. Alright, so another example. Here, we just want to know what the sum of the interior angles for a 17-gon, so 17-sided polygon. So we can just plug in n equals 17 and evaluate. Here's some more music while I evaluate. So we end up with 2700 degrees as the sum of the interior angles of the 17-sided polygon. In this example, we want to find the measure of an angle in a regular nonagon. So, from the terms on the left, we know a regular polygon has equal sides and equal angles. And a nonagon is a 9-sided polygon. I looked it up on Google. Sometimes you have to do that. Now we need to know the sum of all the interior angles. So we plug in 9 for n and evaluate. So the sum of the interior angles is 1260 degrees. But remember, we just want the measure of one angle. So to find that, Since all of the angles are equal to each other in the regular polygon, we can simply divide our result by 9, which is the number of angles of the polygon. And done. Next example. Here we have a regular polygon, so all sides are equal and all interior angles are equal to each other. And we are given that each interior angle is 4 times the size of each exterior angle. So let's draw part of a polygon to show what the interior angle and exterior angle look like. These two segments represent two sides of a regular polygon. To see the exterior angle, we need to extend one of the sides. By doing this, we can see that the interior angle and exterior angle are supplementary, so they add up to 180 degrees. So let's write that down. Interior angle plus exterior angle is 180 degrees. And let's say the exterior angle represents x. And that means the interior angle is 4 times x. Now we can just substitute that in to get an equation with x and solve. Now we just get x by itself with some algebra. We end up with x equals 36. Now we use the sum of the interior angles formula to find the number of sides, n. Let's also write what our interior angle and exterior angle are equal to. We end up with our exterior angle being 36 degrees and the interior angle being equal to 144 degrees. Now let's write the equation for sum of interior angles. Note, since all sides are equal, and we know there are n sides, we can simply multiply the interior angle by n and set that equal to n minus 2 times 180. Now we just solve for n. Isolating n, we end up with n equals 10. So the polygon has 10 sides, with each interior angle being 144 degrees. Now we will look at some examples with properties of parallelograms. So let's label that in our example. Segment WX is parallel to segment ZY, and segment WZ is parallel to segment XY. This comes from the definition on the left. Also from the left side, we see that opposite angles are congruent to each other. So angle ZYW is congruent to angle XYZ. Now we can set the angles equal to each other and solve for x. We have a quadratic equation, so we can get it in standard form and solve by factoring or quadratic formula. Factoring, we see that factors of -20 that add up to -1 are -5 and 4. So we end up with y equals 5 and y equals -4. Only y equals 5 will work since plugging in -4 gives a negative angle. Next example. Here we have a parallelogram and we want to find the values of x and y. Since corresponding sides are equal, we know that segment XY is congruent to segment WZ. So we can set the expressions equal and solve. Solving this quadratic equation by factoring, we get x equals -6 and x equals 3. X equals 3 is the only solution because -6 produces a negative result. We also know that segment WX is congruent to segment YZ. So we set them equal to each other and solve for Y. Solving this quadratic equation by factoring, we get y equals -3 and y equals 1. Y equals 1 is the only solution since x equals -3 gives a negative result. In this example, we will analyze this parallelogram and try to figure out all of the angles from what we know. Angle 7 is congruent to 20 degrees by alternate interior angles. Angle 4 is complementary with 20 degrees, so we can find it by subtracting 20 from 90 to get 70 degrees. Angle 4 is congruent to angle 6 by alternate angles, so we can write that down. We also know that the diagonals of a parallelogram bisect each other, so let's label that. Angle 2 is going to be 20 degrees due to the isosceles triangle property of opposite angles being equal since their sides are congruent. Since sum of triangles is 180 degrees, we can find angle 3 by subtracting the other two angles from 180 to get 140 degrees. 3 and angle 5 are supplementary, so 180 minus 140, which is 40 degrees, is what angle 5 is. And since angle 1 is part of an isosceles triangle, its angle is going to be 70 degrees.